So, good morning or good evening, madam. My name is Clement Shibon Kai, and my next summit is 309620. And today, me and my partners will be presenting about the group assignments. So, what are the topics? So, the topics are how we solve linear equation using programming. So, before that, let us talk about what are the methods that are we using to solve the linear equations. So, first is elementary row operations, that is ERO. That is Gaussian eliminations. Then is matrix inverse methods. So these are the three methods that we are using to solve the linear equations efficiently. So let me briefly explain what are these three of the methods are. So first, elementary row operation ERO. So basically, these methods are basic row manipulations that simplify matrix without changing the solutions. And next, Gaussian eliminations. So these methods applies ERO in a systematic ways to convert a matrix into row echelon form, making the solution easy to obtain by back substitutions. And lastly is matrix inverse methods. So it solves a system by multiplying with the inverse of the coefficients matrix, giving a direct solution when the inverse exists. So this is the short explain of each of the methods. So now we know what are the methods we are using for the linear equation. Let us talk about what are the importance of solving linear equation using programming. So there are several reasons that why solving a linear equation using programming is important. So first of all, using programming can solve large system of equations much faster than manual calculations. Other than that, it also can reduce human errors, especially when dealing with many variables and equations. And not only that, by using programming, it also can help engineers do their job more faster, such as circuit analysis, structure designs, and control system. Moreover, using a programming also can help students understand how mathematical theory is applied in real-world system. So this is some of the importance of using a programming to solve a linear equations. So this is for me. So I will be passing the content for my partners to explain more further. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. Okay, today I will explain about solving a linear equation using programming language. First, my part is I will explain about ERO, which means elementary row operation. What is elementary row operation? It's basically a basic row manipulation that simplify matrix without changing the solution. Right, let's take a look on the example of the code here. As you can see, this is coded using Python programming language. Okay, so I will run the code. So you can see here, it asks of the number of equation. Okay, let's take a look on the example. I will show it down below here. As you can see, there is three equation. So we put in three, but now it asks the number of variable. As you can see, we have x, y, and z, which means three. Okay, now it asks to enter the coefficient of the matrix A. Okay, as you can see, 1, 1 here shows that the position in the matrix, the equation 1, you can see x is 1, y is also 1, and z is also 1. So 1, 1, and 1. Now, for the equation 2, you can type 2, and then negative 1, because minus y, and 1, z. Next, for the equation 3, you can put 1, 0, because there is no y in the equation 3, and then z. Okay. Now, it asks for the value of matrix B. Okay, what is matrix B? It's basically the answer. Right, the answer is you can see equals to 6, 3, and 4 here, down below here. Okay, 6, 3, and 4. Right, now it shows us all the steps, and then the final one will show the solution, which is 1, 2, and 3. Right, now how this works is, first of all, it put out in the augmented matrix shape, which is A and B here. B is the answer. So as we can see here, this is the shape 1, 1, 1, 6, 2, negative 1, negative 1, 3, 1, 0, 1, 4. And this is the shape, the initial shape of the augmented matrix. Now, first step is to change the R1 and the R2, swap the places. Next, we do the operation on R1, which is R1 divided by 2, right? Next one, for the R2, we do R2 minus R1 multiplied by 1. Next, R3, we do R3 minus R1 multiplied by 1. So as we can see, here row 1, we have 1, 0, 0. Now next, we have R2. So for row 2, we have R2 divided by 1.5. Next, we have row 1 is row 1 minus R2 multiplied, my bad, negative 0.5. Okay. Next is R3. R3 is R3 minus R2 multiplied by 0.5. So we can see now the row 2 is actually 0, 1, and 0. Almost solving the equation, but not done yet. Still have to solve for row 3. Now the row 3 is divided by 0.33333. Why? We not put in fraction because this is a computer, so we put in the decimal point. That's why we have row 1. Row 1 is R1 minus 0.66667 multiplied by R3. R3 is 1, okay. Next one is R2 minus 0.3333 multiplied by R3, giving us the final answer of 0, 1, 0, 0, 1, 0, 1, 0 to 0, 0, 1, 3. Like this is the final matrix form. As we can see here on the 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, it's actually the identity matrix form. Okay, and the part of the right part here, 1, 2, and 3 is actually the solution. Here we see the solution is 1, 2, and 3. So then that is how we solve for the ERO on using Python. Right. So I think that's all from me. Thank you.
Good day, doctor. And now, for my part, I will be explaining about the Gaussian method and how our code works. Okay, so wait, let me just close this and then rerun our program. Okay. Okay, so for as our equation as given here is number of equation. Since we're using a 3 by 3 matrix, so number of equation is 3. So let me just enter 3. Okay, and then for the number of variables should also be 3 because we have x, y, and z. Okay, so what our program basically asks now is what is the first element in the first row. So basically the very first equation, what is the first equation? So as for our x only got 1, so we should just type 1. Next, our y is also 1, and our z is also 1. Okay, now it asks for the second equation. So where our x is 2, and then our y is negative 1, and our z is 1. Okay, next for our third equation, our x is 1, our y is 2, and our z is negative 1. Okay, as for the vector, it's basically the final answer of the equation. So here for our first equation, it equals to 6. So we type in 6. And then our second equation equals to 3. So we type in 3. And our final equation is 2. So we type in 2. Okay. Now we have to choose our method. And since I'm going to be explaining the Gaussian elimination, so we choose method number 2. Okay. And then the program basically runs and calculates the answer for us. So as we can see here, it already stated the initial augmented matrix where, x equals 1, y equals 1, z equals 1, where all add, we get 6. 2x minus y plus z equals 3. X plus 2y minus z equals 2. Okay, so what the program does now is it arranges the equations. So here we can see that it swapped places between row 1 and row 2, since row 2 is bigger than row 1. And then we can see here that it starts to get the 0 for x in the second row, and then it does the same with the third row to find the 0. Okay. After that, as we can see here, that the x and y, the y's for equation 2 and 3 is not the same. And for equation 3, it's bigger than equation 2. Therefore, the program swaps the places of the equations, meaning equation number 3 moves up to equation number 2, and equation number 2 moves down. Okay. So that happens here. And then what it does is the program makes it so that the y for equation number 3 is 0. Therefore, we already find the the z for equation number 3, which shows that 1.4z equals to 4.2. So we use the back substitution method, where x3 is basically our z. So z is basically 4.2 divided 1.4, where we get 3. And then for our y, what we do is we basically we use this 3 and put it into this negative 1.5. So that's how we got the negative 4.5. So since 2.5 equals to 0.5 minus negative 1.5 z, so we basically rearrange the algebra. So what we'll get is 0.5 minus negative 4.5. Then we divide it by 2.5. Therefore, we'll get the answer 2. So our y is 2. And then finally, for our x1, what we do is we add in the y value and the z value. Once we do that, we finally get 3 minus 1 divided by 2, as we have 2x. So 2 divided 2 equals 1. Therefore, our x value is 1, our y value is 2, and our z value is 3. Yeah, and it shows the final solution for vector here, which is first element is our x, second is our y, and third is our z. That is all from me. Thank you very much.
Okay, thank you, Clement, for your explanation on how to find the inverse matrix. So I'll dive deeper onto how to calculate it using Python. I'll demonstrate it step by step. So the third question is find the value of x, y, z using inverse matrix. So this is a question. So the first step that is we're gonna separate out the x, y, z here. So we're gonna do the augmented matrix for this one. So you will get 579 and so on for this. And then the second step is to find the determinant for this matrix A. So this is the formula for that one. So you need to multiply it cross to the right side and then minus with the other side cross to the left. In Python array, it looks like this. So later I'll show you. So what you get here is, this is the formula for the determinant matrix. So you'll need to do all this operation and then you'll get 60 at the end. So the third step is to find out the minor. So as you can see, the minor in Python is being declared as AM, BM, CM, DM, EM, FM. The formula is, if you want to find the AM match, the element for the AM, so you need to cross out the horizontal and vertical line for this. So you'll get only 4 elements on the other side. So you need to perform the calculation for this one. So this is the formula. You have to cross, multiply it to the left and then minus with, multiply it with the right. So you get the answer 40 here. and then this is the formula. This is the rules, and then cannot use any numbers that are in the same row horizontal or the same column vertical as the element LM. So the answer at the end is this one, 40, 20, 0, 70, so on. The fourth step is to change the answer you get from a minor, and then find the cofactor of it, and then transpose it to adjoin. So for the cofactor, you need to add negative on these 4 elements, and for adjoin, you need to transfer it, so which means the position of each has been transferred here. The second last is to multiply with matrix B, which we got from the previous question there. So after you perform multiplication, you need to sum up all these rows, and the last step is to multiply it by 1 over determinant, which is 1 over 60, and in the end you'll get this XYZ answer, can be in decimal form or in this form. So right now I'll be explaining the code. So let's execute it first. So number equation equals to 3, which means 3 times 3. So for the element A11 in array, just for easy explanation afterward, as you can see, the first step that the Python has calculated is to find the determinant matrix A. So you expand the first column here, as you can see. So, and calculate out the positive diagonals and negative diagonals, and then perform the operation here. So you get 60 at the end for the determinant. And then the step 2 is find the minus, which I mentioned before, have to cross out the horizontal and vertical line, and then you'll get the remaining to multiply each other and do minus operation. So afterward, so you need to do cofactor for after you're done calculating the minor. So add negative for these 4 elements, and then you do transpose, change the position, and then step 5 you multiply it with the vector the matrix B, so you'll get this one, then you sum up, and then you multiply it by 1 over determinant, which is 1 over 60, and then you'll get this answer. So let's inspect the code. As for Python, NumPy is used for the mathematical calculation, and this operation is actually used to check whether if the determinant is equal to 0 or not. If it is 0, then it is singular, and thus the inverse matrix cannot be calculated. So this function is to make the array out, and then for this one is to calculate the determinant of the matrix. So as you can see, declare the ABC value to the first row A0, second row for A1, the third row for A2. So after that, you need to calculate out the determinant by multiplying all these cross adjustment, and then at the end you need to minus it to get the determinant. And then for this one is to calculate out the minor. This one is for the 2 times 2, but for this case we are using 3 times 3. So here you go. This is the AM, and this is the array for the leftover element after we cross out the vertical and horizontal line for the NM value. And then after that, you need to calculate out the cofactor for each for this 4th element. And then after you have done getting the cofactor matrix, you need to do transpose. Here's the operation C times T. So T is actually a function for from NumPy to do transpose, and then you need to multiply it with the matrix B, and after that the last step is to multiply it by 1 over determinant. So this is the formula, and you return the X value. So this is the main method for this. So yeah, that's all from me. Thank you very much.